Hello friends, today's topic is SNI, server name indication. So in this particular topic we are going to discuss about this concept in depth, what is it all about and how we should use it and check it and all those things. So let's begin. So what is SNI? Now, like you would probably have seen this SSL or TLS handshake. In that handshake there is a client hello packet. In that client hello packet, this is an extension that is added to the client hello. In this particular packet, client hello, the client would reveal which website it wants to access, or that is why it has this name, server name indication. That means which server it wants to access. It tells this thing to the server. And why it does this thing? So that the server can provide the correct certificate. Why correct certificate is needed? Because see, client hello would send the information that I need to access this website. Server would provide the certificate of that website. Now after the server hello, there is a client validation part as well of the certificate provided by the server. So that client validation has to be passed. Otherwise the TLS handshake would not proceed further. Now that is an important catch here. That is why this correct certificate being provided by the server is very important. Now, in order to provide the correct certificate, the server should be aware which website exactly the client is trying to connect to, so that it can provide the correct certificate. Now, why there is a confusion to the server in providing the correct certificate? Client is accessing a website, server has to provide the certificate. Why is this confusion of a correct certificate? Now see, actually what happening is IPv4 had a limit. Those IP addresses are exhausted and there are not much IP addresses left. So in order to save the IP addresses, an attempt was made. What was this attempt? It was made to host multiple different multiple website or multiple domains, virtual servers on a physical server, providing the same IP address and same port number and hosting multiple different websites. Now, why is this important? When there are so many websites on one particular server with the one IP address and one port number, obviously the server needs to know out of those websites which particular website the clients want to connect, so that it can provide the correct certificate to the client and the client validation can be done successfully. So this is the complete crux of this SNI and why it is needed. Let's just proceed forward. Now, this is the most important question. Why was SNI needed in the first place? So we say that this SNI is a client hello extension. Why we say this is an extension? Because in the initial client hello or the initial TLS or SSL handshake, this particular SNI was not there. It came later on. The need for it came later on, and it was realized that okay, we need this SNI feature. Initially it was not there in the original SSL handshake. Why this SNI is needed? Now if we just discuss about that part, the first part is IP address shortage. This we have already discussed. The IPv4, obviously the IP addresses mentioned are getting exhausted. There are not much IP addresses left, so it is very much needed to save those IP addresses. Now you would say that IPv6 has arrived. What is the need to save those IPv4 addresses? See, still there are many devices, many servers, many websites which are still using IPv4. They have not switched completely to IPv6. So therefore, we can't say that we don't need to save IPv4 addresses. We still need to save that. World is still not that advanced. It needs time to settle down on IPv6. So till that time, we need to do this. This is a common name mismatch error. This particular error, when there is an incorrect certificate provided, or there is a mismatch between the what client is requesting as the website and what server is providing as the certificate of that website. If there's a mismatch, then this common name mismatch error occurs. It saves money, obviously. When you are getting dedicated IP address for each website, that means cost. To get a static IP address for each website, it requires cost and renewal and maintenance and all those things. A lot of money is saved when on one particular IP address thousands of websites are hosted. It saves a lot of money. That's why this practice is mostly followed. It is easy to configure and implement. Simple thing. The reason being, the administrator on the client side, if it has to direct the traffic to a particular website, let's say hundreds of websites are hosted on one particular IP, then it becomes very easy for the administrator to configure that traffic flow. He would just mention that particular IP and he can redirect traffic to multiple websites there. So it becomes easy to configure there. This is the private error. Your connection is not private error. You see as an example of common name mismatch error. This is when the traffic is not able to proceed forward. Now there are problems with the SNI as well, and there are solutions or alternatives as well. What are these? The first problem is hostname is not encrypted. When you see the client hello extension and the SNI part, so in this SNI, the request that the client is making for a particular website to the server is visible in clear text. So anyone can take a packet capture and can easily see which website is being requested. So you might be thinking, why it is a problem? See, any attacker, eavesdropper, or a man in the middle attacker who wants to hijack this connection, this information is very important to it. So it can provide duplicate packet, it can provide delayed responses, act as someone else, and can hijack the connection. There are multiple things he can do using this particular information. So the attempt is to secure as much information we can secure during the communication. So this is very important part. Revealing of the host name that the client is trying to access should not be visible. So this is a problem with the SNI, and a major one actually. The other problem that still remains is legacy browser don't support. There are still people who are still using Internet Explorer. That properly doesn't support this SNI feature. You remember when we used to use Internet Explorer in Windows XP, we used to get so many errors. Your connection is not private, your connection is not private, do you want to continue further, and all those things. That was actually this SNI thing, common name mismatch thing. This was happening because there was a mismatch between the certificate and the request. That why that particular thing was happening. So legacy browsers don't support it. Now there are alternatives as well. If there are problems, there are solutions as well. This thing, the very first problem of SNI, that means hostname is not encrypted, is very well solved by this encrypted SNI. So in this, the SNI part of the client hello, only the SNI part is encrypted. Rest all client hello goes as it is. Now it was good, and it was implemented for some time before a better thing, a better option came in. This was the better option, ECH, that is encrypted client hello. So it said, why encrypt just the SNI part, buddy? Let's encrypt the entire client hello. So this is where it came in. But this ECH also has a drawback. What is the drawback? This ECH only is compatible with TLS 1.3. That means the latest one. So TLS 1.2, 1.1, 1.0, all those things, they don't support this ECH. It is an extension that is developed starting from TLS 1.3 only. So older ones don't recognize it. So now it would be implemented. Now we are using more and more of TLS 1.3. So it should be good. But previously it was not. Third alternative is name-based virtual hosting. This is almost the same concept. So the purpose is the same, but it was not taken that well where it should be. Why? The problem being that it used to work quite fine for the website that were HTTP only. They were not HTTPS. See, in HTTP website, since it is not secure, it is very easy for client to reveal the website that it is trying to access in the host header of the HTTP request. So host header can be easily seen. Server would be able to understand which website is trying to access and can proceed forward. But when you try to browse an HTTPS website, the secure one, that means TLS handshake is done before HTTP comes in. That means the server would not be able to reach to the point of seeing that HTTP host header, because obviously in order to go to that point, it has to pass through TLS handshake. And TLS handshake contains this client hello, wherein the client would validate the server certificate. It is very important for the server to know in advance which website is being requested by the server so that it can provide a correct certificate. So this name-based virtual hosting also didn't work well. There is another thing that is actually a good competitor of this SNI, that is called as multi-domain certificates. Now how it works is, in certificate, there are SAN fields, subject alternative names. So that means you can use those SAN fields to put many website or to use many website just by using one particular certificate. So that means just one certificate and you use it for many websites. So it also saves IP addresses. Otherwise, it would have been needing separate IP address, separate certificate for them. But it can be done using one certificate. Now the question arises, if this multi-domain certificate is so good, why we just don't use this? Why we are focusing here on SNI? The reasons are very simple. The first reason is this multi-domain certificate has a limitation of up to 200 domains. It cannot serve more than that. While in case of SNI, it can handle millions of domains on one particular IP address, now you can feel the difference. Where is 200 domains and where is millions of domains? See, that's why SNI is preferred. Lot of overhead in case of this multi-domain certificate. See, when you are trying to manage multiple websites just by using one certificate, obviously complications would arise. Let's say there is a problem with one particular website that was hosted out of those 200 domains. So if there is a problem with one, you won't be able to settle it just by changing for one. You'll have to change or modify the entire certificate. Now you see where the impact is. You'll have to take a complete downtime, complete maintenance window. Then you would be able to resolve that issue with that particular website. Other website, even though they were working fine, still their certificate would be modified due to just one particular website. So this is the catch here. If the certificate needs to be revoked or certificate needs to be renewed, then also these entire up to 200 domains are impacted during that time. Again, the maintenance window needs to be taken and the users would be impacted. That is the catch here. The next thing is visibility to competitors. See, these certificates are provided by the hosting companies like GoDaddy and so on. So these hosting companies provide a certificate to company A, company B, all those things. These companies are competitors to each one. Obviously, they don't want their personal information or their company information to be shared with their competitors. They want to hide it. But if the hosting company is the same, obviously they cannot be assured that it would remain protected. Next is certificate size. If you are using 200 domains on one particular certificate, obviously the certificate size would increase. It can reach up to KBs, many KBs. So in that case, you would think, what is the problem in going it to KBs? See, the problem is when there's a TLS handshake, the very first thing that is downloaded by the browser is the certificate. If the certificate is larger in size, that means it would take more time for the certificate to be downloaded, right? So if the more time is required to be downloaded, then the page would load slowly. You will have to wait. It would keep on loading, and then after the certificate is downloaded, server validation is done and all those things, then only this particular website would load properly. So that is a lot of time. It might take many milliseconds to do that. Until that time, you would just keep on staring the screen. So that is not good. Now there is a drawback. The first thing was for us, but there is a drawback for the companies as well who have those websites or who are hosting those websites. What is the drawback? Drawback is that in today's field, ranking in Google is very important. That means, Acha, you tell me how many times you have gone to the second page of the Google search. We rarely do. When we make a search, we just stick to the first search entry. Whatever those 10, 11 items are there on the first page of the Google search, we stick to them and we don't proceed forward. Actually, this is the thing. Those companies, there are millions of companies serving the same kind of material, same kind of information. Now, it is not possible for millions of companies to be shown on the very first page of a search. It is not possible, practically possible. So that is a huge problem. They are fighting like anything to rank themselves in Google, because if they are able to rank themselves in Google, you would click on those links, they would get the traffic and they would get their earning. So this is very important for those companies. So now going forward to how SNI behaves. So there are things that SNI doesn't do good. Like when there is a mismatch between what client was asking and what the server was provided by the server, then we get this code 112 unrecognized name. It is not able to recognize it and the connection is interrupted. This SNI only supports DNS host names. That is not a big problem, but yes, it is only DNS host names. Extension of type server name in the extended client hello. This is very much important. This extension should be there so that the server can understand which website the client wants to access, so that it can provide the correct certificate. Now, the above things were for those new connection requests. Now, let's say if a client want to resume an old connection, okay, in those cases, there are conditions. The condition is the server name extension provided by the client in the initial full handshake should be the same when it wants to resume the session. Obviously, it makes sense, yeah? When you're trying to make a request for the same website, why would you change the server name? So, this particular thing is okay. Now, look at the second one. This is a bit odd. When resuming a session, the server must not include a server name extension in the server hello. This is disgusting. What is the logic behind it? seriously, I am not able to understand what is the problem if the server would include a server name extension in the server hello. Why it is such a problem? This particular thing I have taken directly from the RFC. So this is correct. In case anyone is aware about why it is what is said so, please do mention in the comments. That would help me as well in understanding this better. How to check if SNI is used? Now this is very important. This is asked in many interviews. How would you identify or how would you know if SNI is being used or not? Simple. You go to this wireshark packet capture, you use these filters sl.handshake.extension type is equals to 0 or equals to server name. So this is if SNI field exists. You would come to know about it. You would see the entries in the packet capture. Now, if you want to check it for a certain domain, let's say twitter.com, then you use this sl.handshake.extension.data contains twitter.com or tls.handshake.extensions underscore server underscore name contains twitter.com. That's very simple. You can proceed with that. This one is the same thing, but a lengthy process. You take a packet capture, you filter only the SSL types of requests using TCP port 443. You find the client hello there. You go to expanding the secure socket layer, then TLS version 1.2 record layer, then go to the handshake protocol, then client hello, and then you would reach to the extension that says server name for SNI. So little bit lengthy, but this is the actual process. The first one that you see on the top is actually a shortcut. Now this is how you would see in the packet captures. You would just type in tls.handshake. You would see the entire handshake. Client hello, server hello, certificate, client exchange, all those things. Now you just go to the client hello. If you are really interested to see the SNI. In the client hello, you would see this particular extension that I have highlighted in the red that says server underscore name. You expand it and you get this extension server name, and it clearly shows which website the client is trying to access. Good. So it should be clear enough. Thank you so much for watching. In case if there is anything that you would like me to explain you further, any other questions that you have, then please do not forget to mention those in the comment section. If you like my videos, please give a big thumbs up, a like, and please subscribe to my channel. Thank you so much for your time. You have a great day ahead. Take care. Bye.